confirmation that you probably got the right answer. Don't just start guessing 42. It's pretty unlikely that it's good. I mean, if you're going to make a guess, guess 1 or 0. That's a better guess. If you look at the statistics of answers over all my tests, I think 1 and 0 are probably more dominant channels. Anyway, so this is FTC3, so don't forget you have to do minus the lower bound's also a function of x, so we have to pay attention to that one too. So we have to do minus the tangent cubed of 1 plus square root of x squared in that case, and then derivative of x squared is 2x, derivative of x cubed is 3x squared, so that's that. This one here, you guys, one of you changed the sinh to like sine, so you put minus cosine here. That's an understandable mistake, but it's hyperbolic sine. So the integral of hyperbolic sine is just hyperbolic cosine. Yeah, so that wasn't a big deal though. That's kind of like, okay. And make a u substitution that brings out a third. So you guys are like, if I had to characterize what's going on, you've got the start of a good u substitution and you're just not following through, right? You got to like follow through, finish the u substitution. I got like a half of a u substitution solution for like a lot of these problems. Here, u is equal to the square root of x. That means du is dx over 2 square root of x, right? Because the derivative of the square root is 1 over twice the square root. And, well, that's convenient because that's what I have there. Dx over 2 root x, that is the du. So I've got e to the u du, which integrates to e to the u, which gives you that. So, this one here, I think one of you tried a secant squared substitution. Yeah, it was that simple. Yeah, just if you see secant squared, that probably means tangent's a good substitution. If you see secant tangent, maybe secant's a good substitution. But you should always try something like, with these kind of problems, secant or tangent is your go-to. If those don't work, I convert to sine and cosine and try like sine or cosine, you know. But yeah. This is a problem we worked in class. Like, this is not an obvious one, but it's also a known problem that you should be prepared for, right? And one of you started down the right path and then got halfway there, I think. So sine cubed is sine squared times sine. So the sine squared I can convert to 1 minus cosine squared. And then I'm like, aha, well, if I make u equals cosine, then this is minus du. So we're in business. And then we integrate, and we get that. So this is a standard trick. Anytime you have an odd power of sine or cosine, you can peel off an even part of it and convert it to the other, either sine or cosine. And then you'll be able to make u either sine or cosine as appropriate.
I did it before that stuff.
So, again here, some of you started right and just didn't finish it. For part E, you make u equal 2 plus x. Then you gotta say, okay, well that means x is u minus 2. So I gotta plug in u minus 2 for my x, and that's the square root of u, and then, so that u times square root of u is u to the 3 halves, and then minus 2 root 2 u to the u half. Then I power rule of integration, add 1, divide by it, you know, and there it is. So. Part F is harder, but this is like one that I worked in the, something I worked like this for you guys. Can't remember what it was. Was it the, do we have a quiz? Did we have, what do we have? I think we had a quiz. We have a quiz?
You just mentioned it.
Didn't we have a quiz like the Wednesday before the,
Oh yeah.
the test? Yeah. Did I give that to you on paper? I can't remember what I'd done in here.
How did we do on that test, by the way?
The quiz?
Yeah.
Did I never get back to you?
Maybe. I don't remember.
Oh. Oh no. I thought I finished everything that I could before break, because I stayed long Friday to like try to Well, I don't want to look at it while I've got the camera going, but I'll look into it. But this one here, so on the one hand, you've got 8x to the 7th power, and the other hand, you've got this 4x cubed, right? So the 8x to the 7th is what du would be for x to the 8th. So that makes a u equals 1 plus x to the 8th, a nice substitution for the first one. And it makes a u equals x to the 4th substitution, w equals x to the 4th substitution nice for the second one. And so I get two rather different integrals. I get a natural log and an inverse tangent, and there it is. Admittedly, this one is more challenging. But I did show you an example like this before the test. It's not completely like just out of the blue. This one here, there were signs of life, but it didn't quite finish for you guys. I think. Actually, I can't remember. You might have got this right. No? Okay. But let u equal x minus 3. Then du is dx. So we get, and then the thing is you have to change the bounds, right? So u of 3 is 0. U of 4 is 1. We plug in the x's into the formula for u. So 3 minus 3 is 0. 4 minus 3 is 1. So 3 goes to 0, 4 goes to 1. We integral from 0 to 1 of u to the 11th, which is 1/12 u to the 12th evaluated from 0 to 1, which is just a 12th. So that's, I really do think that, okay, I mean, I understand if you feel intimidated about part F, right? If you feel intimidated about part F, I have sympathy for you. But the other problems, by and large in here, I think are things you could have gotten right if you just had better luck on test day or something, right? Like maybe a little bit more studying, I'm not sure, right? But I don't think these other problems are things you couldn't do, right? If I asked something similar again, you probably could do them if I asked them again, right? So let's see here. This one, I don't think I did this one. I did something, I might have done this one. I can't remember if I did this one in class or not. I might have. So x squared is below, the squared is on top. Points of intersection are at 0 and 1. That's important because that sets up the integration region, right? It's like, I think you had y bounds. You were looking at y bounds for some reason for this one, which you see why I have to have x bounds, right? For this kind of setup, I need x bounds. And you figure out what x, when you write dx for the area, that means that you're going to do an integration over x, which means you need to find the minimum and the maximum x that you're going over to do the integral, to set it up. And in this one, it's 0 to 1. So I have to integrate from 0 to 1 of y top minus y bottom, and that works out to a third. So this is, I think I've either worked this in class as like our first example, or I've worked something like it in class for sure. But this is I think this is a really good problem. It's not complicated. It's not entirely trivial, but I like this problem a lot. It's a good problem. This is a little bit trickier because it's a sideways one. So some of you had this picture kind of sort of right, but your line was going the wrong way. But that, okay, that wouldn't have actually stopped you from doing it necessarily. But anyway, so I need the right x minus the left x, which in this case is 16 minus y squared minus 5y plus 10 parentheses, So my dA is 6 minus 5y minus y squared dy. And then I need to figure out from where to where. See, I got a dy, which means I need to do an integration over y. I need to find the y minimum and the y maximum to set up my integration. And that comes from the points of intersection, which comes from setting xl equal to xr, which in this case is a beautiful, lovely quadratic, which we can factor and solve. Minus 6 and 1. So that's why I integrate from minus 6 to 1. And it's just a slightly ugly integral, but nothing you can't do. And there it is. Now, is it possible I have a mistake in the integration? possible. I did check this with Wolfram Alpha, so it's more likely that there's an error in the setup, if anywhere, but I think this is correct. But I always hedge my bets a little bit when I have only 2 students. You know, it's better when I have like 15 to check my work. Then if I've got like 5 people with the same answer, and they're usually students that have an A or B on the test, and their answer is different than mine, then it gives me pause, you know. But like there's only 2 people taking the test, so it's hard to, I can't, if I'm wrong, you know. I don't think I'm wrong, but like I said, I did check that with Wolfram Alpha, I believe. Because whenever I do arithmetic like that, I'm always a little bit leery. This one here, I completed the square in the denominator, all right? And then I factor the 9 out to make it look like an arctangent. And then that gives me this. So again, this is challenging, for sure, but I have worked examples like this in class, all right? And I do think that there's more than 150 points overall, so I think there's like 160 or, I think it was 160, if I remember right. Anyway, that's that. So let me just look at something right quick. So I also have tests from spring 2021 in here, right? So let's just take a gander at test 3 from spring 21. What was it? Kind of similar, right? I mean, the first one's almost the same. Might be the same. So like, I cosine squared instead of sine squared, you know. But if you look back at the test from the spring, it's pretty similar to what you guys had. But it's also different, so it would be good to practice from, right? This would be a good thing to practice, especially since you guys are a little bit shaky on the U substitution. Here's some good, moderate U substitutions that you could kind of take a stab at. And the solutions are posted as well, right? So my challenge problem was a little bit more kind of out there. And this one, you can ignore problem 9. We didn't do these this semester, okay? Remember I said we skipped these? So don't tell students from other semesters. I don't want them to know. Anyway, oh, and here's the circle area problem I showed you guys before the test. But anyway. Well, anyway, so I guess that's it for today. So tomorrow we do the lab, and then Thursday is more review, unless you guys would rather just have the day off to study for all your classes. What's your feeling?